All right, guys, so in this video, we're going to be multiplying, okay, polynomials. We're going to start out with multiplying just monomials, all right? Remember, monomials are polynomials with just one term, like 3x squared and 5x to the fourth, okay? We're going to multiply these monomials by using the laws of exponents that we recently went over, okay? So just like in the previous video with adding and subtracting polynomials, I'm going to color code everything here. So we've got 3x squared. Okay, so I'm going to color code the constant part of the leading coefficient here red and the variable expression in blue. Okay, 5x to the fourth, I'll do the same. The reason I do that is we're going to multiply the coefficients together, 3 times 5, and we're going to multiply the bases that are the same, or these exponent terms, variable terms that are the same together, okay, because we can use the law of exponents to combine these two terms, okay? So I multiply the constants, I get 15. Remember, I'm going to add these two exponents. 2 plus 4 is 6. So the product here, the answer is going to be 15 times x to the 6th. Okay? So we're going to multiply the constant terms together. And we're going to multiply the variable terms that have the same base together. And we're going to add those exponents using the law of exponents that we just went over. Okay? In the second example here, we've got constants. Okay, negative 2 and 7. We've got an x term in each monomial, and we've got a y term in each monomial. So let's color code those. So the constants are going to be green, the x's are going to be purple, the y's are going to be blue, navy blue. All right. So the step that I did here and the step that I'm about to show you next, it can be a mental step. It's not a step that you have to show, okay, unless you need to show it while you're still learning the process, okay? So I'm going to group the constants together. So I'm going to multiply negative 2 times 7. I'm going to group the x's together, and then I'm going to group the y's together, okay? And when I multiply each of these, I'm going to just mash them together into one monomial answer, the product here. So the constants, negative 2 times 7 is negative 14. X to the 5th times x cubed is x to the 8th. So negative 14x to the 8th. Add the exponents here, y to the 4th times y to the 9 is y to the 13th. So that should be my final answer for that one, okay? Pause the video, give C a try, and then come back and check your work. All right, so here we've got constants, negative 4 and 6. There's an understood 1 here in front of this a to the 6th. I'll show that in just a second. The a's are present in each of the monomials. The b's are present in each of the monomials. There's no c here, but there is a c term in the second and the third monomial, so we need to deal with that as well. So let's color code everything. Constants, blue, maroon here for the a values, black for the b values, and then the c values are going to be red. Notice I put the 1 in here just so you know it's there, okay? So now let's group everything together. Again, hopefully this becomes a mental step really soon, but if you need to show it, by all means do so, okay? So constants, negative 4 times 1 times 6. A terms, a cubed times a to the 6th times a to the 4th. B terms, b squared times b to the 7th times b to the 1st. And the c terms, just the 2 in red here, c times c to the 10th, okay? So the constants, negative 4 times 1 times 6, well, that's negative 24, okay? A terms, we're going to add all these exponents together. That gives me a to the 13th, so negative 24, a to the 13th. 2 plus 7 plus the 1 that we know is there is going to be b to the 10th, okay? And there's a c to the 1st here times c to the 10th. We're going to add those together and get c to the 11th. So that's going to be my answer for the third example here, okay? So when you're multiplying monomials, multiply the terms together that are the same. Constants times constants, and any variable expressions times other variable expressions with the same base, okay?